Hello, good evening everyone.
सुनो भाई। ये सुन रही हो? ये करीब 8 8 बजे हमारा खुल जाएगा। ये वीडियो ऑन करना हो जाए तुम्हारे को पड़ेगा। सब दिख रहा हूँ। ठीक। हाँ जी सर, आ जाओ, ज्वाइन करो। ज्वाइन करो सर। हाँ जी, हाँ आ जाओ, आ जाओ, आ जाओ। हेलो नीरज। हेलो, हाँ नीरज।
How it works?
गुड मॉर्निंग सर। गुड मॉर्निंग।
How are you?
गुड मॉर्निंग।
Good morning. Can you hear me?
Yes sir, we can hear you sir.
Okay, thank you.
Let me call Sirya sir and Kansal sir.
Okay, let me see. I need to share the screen now.
Sir, how it will be? Sir, are you able to share screen?
Yeah, that's what I'm seeing. What do I have to? Let me first go to my.
Sir, please.
Sir, hello, sir. There is an option in left hand side. Sharing.
Okay, yeah, let me first get to the my presentation.
Hello. 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 Good morning, sir. Good evening.
सानिया ये क्या है
Sir, what happened? Hello.
हेलो
Sir,
हेलो हाँ गुड इवनिंग आशीष
नमस्कार सर नमस्कार नमस्कार
नमस्कार सेठिया साहब
नमस्कार हेलो
क्या हाल है
बढ़िया जनाब आप सुनाइए
बस ठीक है हम लोग भी ठीक है भाई ये कहाँ पे ऑफिस में बैठा है
नहीं नहीं
हाँ।
घर पे
तो घर पे ही कुछ बोर्ड वोर्ड लगा रखा है क्या क्लास लेता है क्या
एक लगाया था ऐसे शौकिया पहले
अच्छा
काफी दिन से यूज नहीं किया वैसे
हाँ जब तक नहीं होता तब तक तो आदमी सोचता है कि हाँ यहाँ पे भी ये कर लो वो कर लो
आदत तो बरकरार रहे
पता नहीं कब तक ऐसे रहना पड़ेगा
हाँ बिल्कुल बिल्कुल
ये बात सही है। विकास आ गया क्या
हाँ विकास यस हाँ
ये कौन सा मोड है ये वेबिनार का ये भी अलग ही सिस्टम है।
सर
हाँ नमस्कार विकास।
नमस्कार सर।
ये कौन सा सिस्टम है भाई? ये जिट्सी क्या है ये?
Jitsi, sir, I do not know. Our IT section they have given this,
अच्छा अच्छा
but it is connected with YouTube so that everybody can see.
अच्छा।
सर अभी बीपी सिंह सर आए थे सर, तो पता नहीं कैसे फिर
So
आउट हो गए सर।
any number of people can join here.
Yes, yes. Through this, they are connected at YouTube. So any number of persons can join at YouTube. Giving ring to BP Singh sir.
विकास।
हाँ 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 सर नमस्कार सर।
हाँ, अच्छा ठीक है। हाँ,
कैसे हैं सर?
मैं
Good evening,
ठीक हूँ,
sir.
आप कैसे हैं?
गुड इवनिंग सर।
नमस्ते भैया।
चलिए आज तो आपका ये ठीक आ रहा है, आवाज भी ठीक आ रहा है सर, वीडियो भी ठीक आ रहा है।
देखिए ठीक चलती रहे तब है ना।
ये सर आपकी खिड़की की जो पीछे की लाइट आ रही है ना सर, वो बहुत ज्यादा आ रही है।
सामने की लाइट।
अगर थोड़ी सी बैकग्राउंड में ये जो पीछे की कर्टन हो या कुछ इस टाइप से हो तो ज्यादा अच्छा आएगा सर।
सर के हाँ पीछे लाइट आ रही है, लाइट इज कमिंग।
हाँ सन
Yes, sir.
सन आ रहा है ना, सन की वजह से थोड़ा सा।
हाँ जी सर, आर यू एबल टू शेयर योर स्क्रीन?
हाँ अब ठीक, अब
कैन यू हियर मी नाउ?
बेटर नाउ।
हाँ अब बहुत
Yes,
अच्छा
sir.
है सर,
Yes,
बहुत
sir.
अच्छा है।
तो लेट मी शेयर द स्क्रीन।
प्लीज
कैन यू
शेयर योर स्क्रीन सर, प्रेजेंटेशन आप एक बार शेयर कर
कीजिए?
शेयर स्क्रीन सर।
कैन आई शेयर?
विकास थोड़ा बता दो। हाँ
कैन यू
बता दो
सी
विकास,
स्क्रीन?
कहाँ से हुआ?
क्या देख आशीष देख
नहीं
पा
सर,
रहे हैं?
Yes, sir.
आपकी स्क्रीन नहीं आ रही सर, कंप्यूटर स्क्रीन नहीं आ रही आपकी, वीडियो दिखा।
तो मैंने तो मैंने शेयर योर स्क्रीन आइकन दबाया है, तो उस पर तो मेरे को तो दिखाई पड़ती है।
अभी आया नहीं सर,
नहीं आया?
नहीं सर।
Even let me check with my son.
Sir, you have to click on the option your entire screen, then it will be shared to us.
Okay, okay. I share the screen.
And click on your entire screen. Now, yes, we are seeing now. Now minimize the other windows. Open your presentation only.
हाँ अब आ गया सर।
Now you can see.
हाँ, अब ये एक्टिविटी उसको प्रेजेंटेशन मोड में ले आओ सर।
Yes.
Minimize this window, sir. Minimize this window.
This window.
Yes. Minimize this and click
इसको भी
on the.
minimize?
No. You just have to click on the स्लाइड शो
स्लाइड शो पे ही क्लिक किया अभी हमने।
ये पीपीटी मोड में जो नीचे से डाउन स्ट्रीम में जो है परसेंटेज इज जस्ट लेफ्ट में
यस स्लाइड शो ऑप्शन
आइकन को राइट पे लेके जाओ सर, राइट में नहीं, राइट पे लेके आओ सर, बिल्कुल राइट में नीचे साइड में।
F5 से
एक्सट्रीम राइट में।
यस
हाँ,
यस सर, ये सर, ये
ये-
अभी आप आए थे सर, अभी आप आए थे सर, यू वर देयर।
इसके ऊपर थोड़ा सा
नहीं सर, इसके ऊपर
इससे
सर,
पहले ये
ऊपर आ जाइए सर, ऊपर वाली रॉक बार पे आइए सर, ऊपर वाली। हाँ यहाँ सर, नीचे 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 सर, इस पे ये व्हाइट। हाँ
अब आ गया, ठीक ठीक है सर, ठीक
but I cannot see you.
कैन वी स्टार्ट सर?
Yeah. Okay, so they will ask me questions.
सर कैन आई स्टार्ट?
Yeah, we can start.
Yes sir, so good morning to Dr. Yes sir.
No, but I like to see their faces on the side. No, I was able. Okay. Okay.
Can I start sir now?
Yeah, we can.
Yes sir. Good morning to Dr. VP Singh, and for all of us in India, a very good evening. Respected Professor Dr. VP Singh, Distinguished Professor Caroline and William N. Lehrar, Distinguished Chair in Water Engineering at Texas A&M University. Honorable Vice Chancellor Professor Dr. R.C. Quad, Central University of Haryana. Respected Professor Dr. M.L. Kansal, Professor and Head, WRDM, IIT Roorkee. Respected Professor Dr. Baldev Sethia, Professor, NIT Kurukshetra. Respected Professor Dr. Ashish Pandey, Professor, WRDM, IIT Roorkee, Secretary, IWRS Society. Deans, HODs, my friends, faculty from other institutions, and dear students, it is my proud privilege to extend a very warm and cordial welcome to all of you for this webinar on behalf of Central University of Haryana. First of all, I would like to extend a hearty welcome to Professor Dr. VP Singh, who has been very kind enough to accept our invitation for delivering a lecture. This is indeed a matter of great pleasure for us that he is here with us today in this webinar. I welcome you, sir. I would like to extend a very warm welcome, Honorable Vice Chancellor Professor Dr. R.C. Quad, for blessing us and for all valuable guidance and motivation for today's webinar. This webinar could not have been materialized without his guidance. Due to some urgent meeting, the Honorable Vice Chancellor sir could not join us in this webinar. However, we are sure he will join this webinar after his meeting. Now, I would like to express our sincere gratitude to Dr. M.L. Kansal for accepting our invitation to be present in the webinar as a panel member. I welcome you, sir. In this same breath, I would like to extend warm welcome to Professor Dr. Baldev Sethia for sparing his precious time for this webinar as a panel member. I would like to extend warm welcome to Dr. Ashish Pandey, Professor WRDM, IIT Roorkee, and Secretary IWRS for attending this webinar. I welcome you, sir. I once again welcome you one and all. Hope you will have fruitful and useful deliberation during this webinar. Now, I for this webinar. It is my honor and privilege to introduce Dr. VP Singh. Professor Dr. VP Singh is a distinguished professor, a Regents Professor, and the inaugural holder of Caroline and William N. Lehrar Distinguished Chair in Water Engineering at Texas A&M University. He received his BSc, MS, PhD, and DSc degree in engineering. He is a registered professional engineer, a registered professional hydrologist, and honorary diplomate of ASC AAWRE. He has published extensively in the area of hydrology and water resources, including 30 textbooks, Handbook of Applied Hydrology, Encyclopedia of Snow and Ice Glacier, 71 edited books, 114 book chapters, 1293 refereed journal articles, 330 conference proceeding papers, or 13 special edited journal issues, 50 book reviews, and 72 technical publication and reports. For his seminal contribution, he has received more than 93 national and international awards, as well as 3 honorary doctorates. He is a member of 11 international Science Engineering Academics. He has served as president of American Institute of Hydrology, chair of Watershed Council of American Society of Civil Engineers, vice president of Indian Association of Hydrologists, vice president of Association of Global Groundwater Scientists, and is currently president of American Academy of Water Resource Engineers. He has served as editor-in-chief of 3 journals and 2 book series and served on editorial boards of more than 25 journals and 3 book series. His Google citations are 63,024. H index is 110 and I-10 index is 977. Before handing over the stage to Dr. VP Singh, it is my honor to inform the gathering about the panelists among us.
And he
We have
and he is a distinguished professor in our department also.
Yes, sir. He is a distinguished professor in IIT Roorkee also.
Yes.
Dr. Vithalal Kansal, currently working as a NIPCO chair, professor and head in the Department of Water Resources Development and Management at IIT Roorkee. He has more than 32 years experience in teaching, research and consultancy. He is civil engineering graduate with post-graduation in water resources. He has published more than 150 research papers and 2 books. Previously, he has served in Delhi College of Engineering, NIT Kurukshetra, IIT Delhi, NIH Roorkee, and at various levels. We have also another panelist member, Dr. Baldev Sethia from NIT Kurukshetra. Dr. Baldev Sethia is a professor in Department of Civil Engineering of National Institute of Technology, Kurukshetra. He has more than 34 years of experience in teaching, research, and consultancy. He is civil engineering graduate with post-graduation in water resource. He is from NIT Kurukshetra. He was awarded his PhD by IIT Kanpur. He has published more than 150 research papers in international and Indian journals and conferences, including 3 patents under intellectual property rights. Dr. Sethia has worked in different important positions, including that one of the directors of All India Council for Technical Education, principal in Engineering College, Maulana, and as a dean academic at NIT Kurukshetra. Now we have Dr. Ashish Pandey, Secretary IWRS, Indian Water Resource Society, IIT Roorkee. Now I would like to read his resume. Professor Ashish Pandey did his BTech in Agriculture Engineering and MTech in Soil and Water Engineering from JNKVV, Jabalpur. He received PhD in Agriculture Engineering from IIT Kharagpur. Presently, he is working as a professor at Department of WRDM, IIT Roorkee. He guided 10 PhD, 78 MTech students at IIT Roorkee. He published 155 research papers in peer-reviewed and highly impact international national journals, seminar, conferences. His laurels include Eminent Engineers Award 2015 given by Institution of Engineers Uttarakhand State Center, DART Scholarship and ASP Scholarship. He was offered prestigious JSPS Postdoctoral Fellowship for Foreign Researchers, Japan, and Boycott Fellowship of DST GUI. He is a fellow member of Institution of Engineers, Indian Association of Hydrologists, and Indian Water Resource Society. Now, at present, he is working as a secretary of this IWR Society. We are privileged to have Dr. Ashish Pandey here. So I would like to request Ashish Pandey sir to apprise us about IWR in brief before giving mic to BP Singh sir. Please, sir.
Thank you, Professor Gar. My greetings from Indian Water Resource Society. First of all, I am thankful to you for inviting me in this mega event. On behalf of Indian Water Resource Society, I welcome Professor VP Singh, Texas A&M University, USA, and Distinct Professor, WRDM Department, IIT Roorkee, Professor R.C. Kuhad, Honorable Vice Chancellor, Central University, Haryana, Professor M.L. Kansal, Executive Vice President, Indian Water Resource Society, and Head Department of WRDM, IIT Roorkee, Professor Baldev Sethia, Professor Department of Civil Engineering, NIT Kurukshetra, Dr. Ajay Kumar Bansal, Dean School of Engineering, Central University, Haryana, Dr. Neeraj Kumar, Coordinator, Student Chapter, Central University, Haryana. It gives me pleasure that Department of Civil Engineering, Central University, Haryana, and the Student Chapter of Indian Water Society is organizing a webinar on water resource challenges and research need. This is right chosen topic because now we are listening a lot of news from all over India that now people are facing water scarcity in many places. Now let me tell you in brief about our society. This society was founded in 1980 as a society registered under the Society Registration Act. Head office of IWRS is located in the Department of WRDMIT Roorkee. In addition to that, IWRS has local center and
This
student chapters in major cities and reputed colleges. Subject to approval by the executive committee, membership of IWRS is open to any person who is interested to in water sector. The specialty with this society is that one doesn't have to be an engineer to be a member of IWRS. This is a truly democratic institution. This accepts those members as who are known to hold a view contrary to IWRS institutional view also. At the last count, we have around 8,000 individual members, 335 fellow member and 48 institutional member. The main objective of the society is advancement of knowledge in technical and policy aspects of water resources development and management. This serves as a platform for free and frank discussion amongst those concerned with water related issue. Although headquarters of IWRS is located at Roorkee, but our centers are also very active and they are organizing many activities which are having some national and international importance. Thank you.
Thank you, Ashish sir, for briefing about the IWRS. Now I request Professor Dr. VP Singh to share his valuable thoughts as you are pioneer in this field. Sir, please. VP Singh sir, please sir.
माइक अनम्यूट कर लें. You should unmute his mic.
Sir.
Yeah.
Yes. Please unmute your mic.
Huh?
Yes, sir. Minimize. Sir.
This one?
Yes, sir.
Which one? This one?
No, no.
This one?
Last one.
Right.
No, no. Right, sir. Right. This one. This one. Yes, sir.
Can you hear me?
Yes, sir.
Yes, sir. We can hear.
Okay. First of all, thank you so very much for a very graceful prelude. Dr. Kohad, Vice Chancellor, who is not here, but hopefully he will join a little bit later. Dr. Imran Kansal, Dr. Baldev Setia, Dr. Ashish Pandey, Dr. Vikaskar, and all the seminar participants. First of all, it's good to see all of you, my friends, especially during this coronavirus or COVID-19 pandemic. I am pretty much homebound, and I suppose you all are as well. In any event, Vikas asked me to give a very general seminar on water resources, primarily aimed at graduate as well as undergraduate students. So I chose the topic of water resources challenges and research needs, which I think might hopefully be of some interest to the students, particularly those of you who are already engaged in water resources research may not find anything new in what I will be saying, but I'll share with you some of my personal thoughts on what exactly is going on and how we should go about managing our water resources. So with that, let me first review what we will be discussing. So we will be discussing essentially four main topics. First, the main mission or the tasks of the water sector, and then of course the challenges that the water sector faces, not only in India but all over the globe. And then of course the strategies for meeting these challenges and what the research needs are. Now, in many ways, this will be more like a personal reflection of what I think the research needs are. Of course, those needs vary from country to country, from locality to locality, and of course from one organization to another, because water being such a vital resource, its needs, its demands vary. So let's look at the first major task of the water sector. Mainly the tasks include water supply, water quality management, disaster management, power generation, navigation, conservation of natural resources, the natural systems and sources, groundwater management, recreation, river basin management. These are actually some of the major tasks that the water sector is tasked with or charged with. Now, of course, this is not by any means an exhaustive list of all the tasks that the water sector is responsible for, but at least it gives a sample of the major tasks. So the first one is, and the second is really the water supply. We need water for domestic purposes, for irrigation, for industries, for power generation, for navigation, for waste management, for recreation, and for ecosystem sustenance. In other words, the water supply is needed for our way of life or life, for our life. So let's first see, how much water is really available. If we look at the hydrologic cycle, we find that nearly 97% of the global water that is available in the globe is pretty much saline water, which means it's not really usable. And about 3%, and I'm using these numbers in a qualitative sense because these numbers are not precisely defined. These are kind of approximate figures. So don't take these numbers precisely at their face value, but there may be minor variations here and there. So about 2.5% of the available water is really fresh water, which amounts to approximately 35 million cubic kilometers, and only about 0.8% of that is usable, because which amounts to 12 million cubic kilometers. And 1/3 of this is essentially polluted, which means about 8 million cubic kilometers of water is essentially polluted. So where all this water actually reside, not directly usable, and about 30.1% is available in the form of groundwater, and about 0.26%, which is a relatively small number, is available in lakes. But even that number amounts to 105 K cubic kilometers. So K stands for thousand, and only 0.006% is available in rivers, which is around 2,500 cubic kilometers. So you can see on a relative basis, our focus has been primarily on rivers, which really contain a very small percentage if you look at in a global context. And much of our focus, not even though that represents almost a very small fraction of the global available water resources. So where the fresh water is available, if you look at the world map, you find that in India, we are not really all that in a good position. This is partly because of very large population and not correspondingly as large an area, even though we are the sixth largest country. But unfortunately, the next large country, in other words, the next country which is larger than India, is almost 2.5 times bigger than India. So, and of course, there the population is very small. For example, Australia has less number of people than in the entire Delhi greater area. In other words, if you include the population of Delhi, Meerut, Bulandshahr, Ghaziabad, and Gurgaon, and within a radius of about 60 to 100 kilometers, the population of this area is larger than the whole continent of Australia. So that explains the dilemma that we find ourselves in. Now, currently, on a per capita basis, the water resources in India have declined below 1700 cubic meters per year, which is what is needed for a healthy life or for healthy living as indicated by the United Nations. So we are way, way short. In fact, we are bordering almost on the line of being water stressed. We are already, or water scarce. We are already a water stressed country. And I'll show you a little while ago how we were only about 60, 70 years ago. And as you can see that there are not really that many places which are water surplus countries. Even those places which once upon a time were water surplus are no longer in that category. And of course, if you look at the continent of Africa, it is in much worse shape. If you look at the continent of Australia, even though Australia does not receive as much water as India does, but it is a water surplus in the sense that it has very, very low population. So that actually gives a little bit of a picture as to how we are doing in terms of freshwater availability with respect to other countries. Now look at how much water really we have. If you look at the water balance for India, the average annual precipitation is 4,000 cubic kilometers, which is relatively high. Uh, but unfortunately, about 700 kilometers is lost to the atmosphere, and 2,150 goes into the ground, and the surface runoff is only around 1,150 cubic kilometers. So the total water sources we are left with, which is available for consumption, is only around less than 2,000 cubic kilometers. Of that, utilizable water is only about little over 1,000 cubic kilometers. So on the left side, you see the total population in billion, and then of course on the x-axis you see the years. In the year 2000, our population was really quite small. It was only 1.2 billion. Now in 2030, the projection is that we will exceed the population of China. Actually, we have already crossed 1.35 billion. I think if we believe the government figures, and perhaps we may be even more populated than what the government statistics show. But again, even that is not really the issue here. The issue is that our population continues to grow at an alarming rate. If you look at the rate itself, it is not that high, but the bulk population already is so huge that even a small rate of increase makes the volume much bigger. So if you look at on the right side, the figure that shows that even in 1960 or before that, we were actually a water surplus country. But by the year 2000, we essentially fell in the category of water stressed. And now we are bordering on being water scarce country. And this is because of the two reasons, but largely because of increasing population. There is nothing that anyone can do about it. The water is endowed by the nature. We cannot increase it. All we can do is manage it. And that's where actually the focus should be and will be. So, and the compounding this problem of freshwater availability is precipitation variability. Now, if you look at the variability in precipitation, we are one of the few countries in the world that experiences a very large precipitation variability. For example, if you look at our country, along the Western Ghats, particularly all the way up to the southern tip, as well as on the northeastern side, we find that the precipitation is very highly variable. In fact, the maximum variability can be as much as 2,000, even more than 7,000 uh, millimeter on an yearly basis. So that complicates the problem of water management. And the same thing applies to runoff variability. Of course, the runoff variability is not as big uh, as the precipitation variability, partly because of human management, but still we have a pretty high runoff variability in terms of millimeters per annum or per year. These are some of the problems that we are constrained by. Now, impacting this variability and compounding the challenge for water resources management is climate change and its impact. So let's spend a few minutes. In 2000, at the World Water Economic Forum, in Davos, Switzerland, the climate change was declared as the greatest challenge facing the world at the beginning of the century, which means beginning of this 21st century. And we are in the first part of the 21st century. And Jack Straw, the British Foreign Ministry in 2004, wrote an article published in Daily News. And the gist was that this is the climate change, the most important long-term issue which we face as a global community, as a society, in fact, as a civilization. So let's first, before we deal with the climate change and its impacts, let first, and this is primarily, as I said right at the outset, my seminar is primarily directed at students. So let's first see what we mean by weather. Weather is essentially the state of atmosphere at a given time and place with respect to the variables such as temperature, moisture, pressure, etc. This is something that we refer to almost on a daily basis. We always say, how is the weather? That's what essentially we mean. On the other hand, climate is the average weather. Average. So in other words, when you talk about averaging, that means it's a statistical description of mean weather conditions over a period of several years. Now, typically, the period of several years is taken to be 2 to 3 decades, in other words, 20 to 30 years. So the climate change then essentially is an axis of natural variability, and it is attributed to human activity. So let's see, if you look at the diagram, and on the left side, in the upper part of the panel, you will see natural climate variability. So in other words, the climate is always variable. It has been ever since the birth of the Earth. But if you look at the second circle on the right side, again in the left part of the screen, then you will find that the climate is no longer changing in a manner that it used to, partly because of anthropogenic factors. So if you impose the impact of anthropogenic factors on the natural variability, and that's what we see. In other words, the fluctuations are somewhat random and they are much larger. So what those anthropogenic influences are, which change the climate, and those anthropogenic influences have been since the birth of industrial revolution. Now, of course, primarily those influences are spiraling population, very high pace of industrialization, increasing use of fossil fuels in industry and transport, particularly in automobile and of course in industry, and then also deforestation for agriculture as well as urbanization. these are some of the things. They are not everything, but these are some of the anthropogenic influences which have a major impact on the climate, or in other words, which are the primary causes of climate change. So just in a nutshell, what does climate change essentially is reflected by? It is reflected by global warming, increased precipitation and its uneven distribution, melting of glaciers and snow, and sea level rise, increase in frequency and intensity of extreme weather events. This is what something we have been witnessing, and this is happening in India, particularly in northern India. I come from Agra. In my village, I've been observing that for the past 4 or 5 years, in the month of May, in the month of June, we get extreme windstorms, which almost like what we call in the US as tornado. And many times they are accompanied by extreme rainfall. Last year, the combined impact of extreme rainfall and extreme wind in my rural area was so huge that almost 80 to 90% of crops which were already harvested were completely wiped out. The farmers could not even see a single grain. Everything was blown away. So the impacts of this climate change is partly witnessed in terms of uncertainty in water availability, decrease in crop yields, and then of course we have to find new sources of energy, and of course we witness it in terms of loss of biodiversity and also increased health risks. There are all kinds of other issues that we will briefly discuss. If you look at the fourth assessment report of IPCC, this inter-governmental report on climate change, and of course we have newer reports, but the newer reports reinforce what was stated in the report published in 2007, and it says that approximately 0.6 degree increase in Celsius increase in temperature has been experienced on average during the last century, and 11 of the last 12 years have been the warmest since 1850, and with the 1998 being on the top. Also, it has been projected that the temperature increase over the 21st century will be on the order of 1.1 degree to 6.4 degrees Celsius. And the expectation is that the most likely range will be 1.8 to 4 degrees Celsius. Associated with this will be large changes, both increases and decreases of temperature and precipitation in different regions of the world, and of course the frequency and intensity of extreme climatic events such as severe cyclonic storms, floods, droughts will increase significantly, and there will be large-scale melting of mountain glaciers and polar ice caps, particularly the Arctic, and there will be a substantial rise in the sea level. And just to reinforce the increase in temperature, if you look at the graph from the year 1000 to 2000, then you find that all the way up to almost 19 to the the decade of the 1990s, the temperature was kind of going up. The temperature started going around 1965 or 1970, depending upon where you are located. But then from the middle of the 19th decade, the temperature started rising sharply. Now, sharply means the departure or the increase, even though in terms of the absolute increase, you may find the increase is not that really large, but a small increase in temperature has major consequences on biodiversity, on human health, on evapotranspiration, on everything else. So if you look at the second graph, you can see that from the middle of 1960s all the way up to now, even though we don't have the figures up to now, there is in terms of the differences from the mean, the increases have been very, very large. And as I said before, the 12 warmest years, beginning with 1998, consecutively actually have been um, in this century as well as toward the end of the last century. I mean, so this is where the problem is. And below the graph, you will find that the rate of change in the temperature from 1850 to 2005 is only 0.045 degrees, but then it has sharply increased thereafter. So why are we witnessing global warming? This is because of the greenhouse effect. So if you look at this diagram shows, excuse me, shows that the solar radiation actually, it passes through the atmosphere. The solar energy that we receive from the sun, it comes through the atmosphere. But then, of course, some of the solar radiation is reflected by the earth and some by the atmosphere. But then what happens? And this reflection, you can see approximately 30% is reflected by, and of course, the solar radiation that is reflected back is long wave radiation. The solar radiation that is received on the surface is short wave radiation. Then what happens is some of the infrared radiation, when it passes through the atmosphere, it is absorbed, some of it is absorbed by the gases, and it is re-emitted in all directions by the greenhouse, what we call as the greenhouse gas molecule. So basically, these gases which absorb the atmosphere and then later on actually reflect in all directions, including getting back to the earth. So basically, these gases create some kind of an umbrella, just like the greenhouse gases. In the greenhouses where we grow vegetables, basically we try to maintain a kind of a constant temperature. That's what happens. That's the reason we call it all these gases, greenhouse gases, and the effect is termed normally as greenhouse effect. So changes again, the climate change impacts again in terms of freshwater availability, freshwater storage, rainfall variability, runoff variability, flow variability, extreme weather events, floods and drought, water quality erosion. These are some of the hydrologic consequences of climate change. So this, from a hydrologic viewpoint, obviously, one can summarize in just one sentence, that is intensification of the hydrologic cycle. That's where the major impact of climate change is felt. It intensifies the hydrologic cycle. So what does this intensification essentially translate into? It translates into more floods, more droughts, more variability in rainfall, shorter snowfall season, early spring snow melt, and accelerated glacier melting. And then, of course, all these impact then water availability, water quality, the ecosystem, the biodiversity, everything essentially is impacted then by climate change. So if you really look at this again, pretty much summarizes in a peculiar form the climate change and water. So basically, there is a climate change, it leads to deglaciation, which leads to glacial lake formation, and then glacial overflow or flooding. It also leads to snow cover decline, permanent snow cover decline, and it changes, that changes wetland, also permafrost decline, and which means it changes the biodiversity because it immediately changes our ecosystem. And these changes then, they essentially, all these lead to changes in the entire hydrologic regime, meaning the changes in hydrologic cycle, hydrological droughts, extreme floods, like, and hydrological shifts also. And these have major consequences in terms of water, in terms of agriculture, in terms of biodiversity, and in terms of health, in terms of the entire social spectrum, and which means our entire well-being is impacted by climate change. So what are we doing then to mitigate or at least to reduce climate change? Now, of course, the climate change is being addressed by several national research programs in almost all developed countries. A number of developing countries, including India, are also actively pursuing climate change research. In South Asia region, India has some 20 establishments. In Bangladesh, Nepal, Sri Lanka are also engaged in climate change research. China has a large number of establishments engaged in climate change research. So there is some global response, but the global response is really not as much as it should be, because we are still contributing to climate change. On one hand, we are trying to understand climate change and its impact, and we are also doing at least something to reduce the impact of climate change. In other words, to reduce the change itself. But we are not doing as much as we should be, and there are some activities which we can easily do without impacting our way of life, our standard of living. Say, for example, afforestation. I mean, that can be easily done without impacting anything, but we have to cultivate the culture of planting trees. Um, and so the climate change essentially poses a number of challenges, particularly in terms of water challenge, food security challenge, climate extreme event hazard challenge, and the ecosystem challenge. These are some of the challenges that we have to grapple with. And of course, the water quality management, because it impacts pollution abatement and control, river restoration, treatment facilities, recycling, fertigation, watershed management. So all these things are essentially, so the second task of water sector was water quality management. But all these activities, in other words, the entire water quality management is impacted by climate change. And then, of course, another task was disaster management. How do we control floods and how do we manage them? How do we manage drought? And dam breaching is another problem, particularly um, arising when there is a major flood. And of course, the coastal erosion. Whenever there is a huge storm, the entire coast is wiped out. And of course, so we have to manage the entire ecosystem. And of course, the fourth one is the conservation of natural resources. How do we conserve our surface water systems, particularly rivers, lakes, reservoirs? And how do we conserve our groundwater systems? And then, of course, the land surface systems and coastal systems. Because these are our natural wealth that we have. These are our natural treasures. So how do we conserve? We just have not cultivated as a population the nurturing and the sustaining and the restoration of these natural treasures, even though in our cultural traditions and our social institutions, we worship. Ours is the only country where lakes, where rivers are worshipped, and yet we abuse them. It's a contradiction in terms. On one hand, we revere them. We have slokas that we chant in the mornings. On the other hand, we don't really pay much attention to nurturing them, to preserving them, to restoring them, to basically taking care of them and managing them. We just don't. And because somehow or other we lost our way in the way we live our lives. So, what are the factors which compound the tasks that the water sector, not only in India, but everywhere else, is charged with? Obviously, first we have limited availability of water, so that's a major constraint that we have to grapple with. We have to accept it. There is nothing we can do about it. And then, of course, the another task is because the availability of water is so uneven, and of course, our irrigation, which consumes nearly 80% of all freshwater resources, is less than optimal. And of course, we have less than optimal agricultural practices. And climate change and, of course, the global warming are not helping us. And then, of course, on one hand, we have burgeoning population, and there is uneven rise in population. This also creates a challenge for the water sector. Partly this arises because of migration from rural areas to urban areas, and partly, of course, the rise is the natural rise. And then, of course, there is a rising demand for water, and then, of course, there is a huge mismanagement of water resources. So, what are then? Let's first look at what the grand challenges in the 21st century are. In the 21st century, the grand challenges are basically you can summarize in two words: life security. This is this is comprised of water security, food security, energy security, environmental security, ecological security, and health security. But none of these six securities or five securities is possible without water security. In other words, food security is fundamentally dependent on water security. Energy security is fundamentally dependent on water security. Environmental security, ecological security are fundamentally dependent on water security. And to a large extent, health security is also dependent on water security. So let's look at those challenges then in the light of these securities. First, water availability. So what we mean by water availability, there should be enough water to all the people at all places at all times at affordable cost. That is when we will say that water is available. Unfortunately, we don't have enough water. We don't have enough water for all the people. We don't have enough water at all the places, and we don't have enough water at all places at all times, and we don't have enough water at affordable cost. So in fact, none of the attributes of water availability is currently satisfied in our country. Second, of course, water quality. In other words, there must be adequate quality water to all the people at all places at all times at affordable cost. And the same thing applies to the attributes of water quality. We just don't have enough uh, quality water. And so the question arises, have we as a society met the challenge? Of course, the answer is emphatically no. Can we meet the challenge? The answer is yes, but with certain constraints. So are we doing what we should be doing to meet the challenge? And my answer is partly yes and mostly no. So how do we then meet the challenge? First, there has to be a paradigm shift. We have to think out of the box, and we have to manage water resources at the water steady state. But more importantly, we have to develop a culture of management and conservation. We have to manage water resources supply, we have to manage water resources demand, we have to manage water resources storage, we have to manage water resources use, and we have to ameliorate, we have to eliminate waste. Unless we do these five things, which means unless we cultivate the culture of management and conservation, there is no way we can meet the challenge. So basically, again, this is in a graphical form: availability of water, supply of water, demand for water, need for water, use for water, and strategy. So whatever the strategy for meeting the challenge is, we have to manage the availability, the supply, the demand, the need, as well as the use. So the question is then, how do we actually manage under climate change? First, look at water supply. We have to have a more diversified portfolio for water supply. So new surface and groundwater sources, and we have to better manage, meaning we have to increase efficiency. Unfortunately, there are not that many new surface and groundwater resources actually left. So which means our focus has to be on better management with increased efficiency. Now, of course, we have to grapple with the sea level rise. The size and intensity of storm may increase. Saltwater intrusion in coastal aquifers is likely to increase as sea level rises. The saltwater beds will start migrating inland. It has already started, but it will migrate further inland. And existing infrastructure facilities were designed using hydrologic records that did not reflect the effect of anthropogenic climate change. So planning of all new projects should include the impact of climate change. And then, of course, that also means that there will have to be a systematic review of all infrastructure facilities, particularly large facilities that serve the needs of the public, and especially those that have a high risk of failure or the risk of high damage in the case of failure. Those are the things we will have to do. So how then we do uh, water management in a sustainable fashion? First, we have to do integrated watershed management. We have to do integrated water resources management, and the decision making has to be multi-criteria, multi-objective, multi-constraint, and there will have to be a socio-economic evaluation. Now, of course, the integrated means we'll have to start gathering data, processing them. We have to have obviously whatever modeling or whatever actions we take, they must be verified. There must be an analysis of risk and uncertainty before we implement the projects, and we have to learn from the implementation. And this experience must be reflected back into the project operation and management. And there will have to be a public participation. So in other words, what I'm saying is that there will have to be a participation between the government agencies responsible for managing water resources and the public for which the water resources projects are designed, developed, and implemented. Likewise, the institutions, especially the research and academic institutions, also will have to be factored in. So there will have to be a close-knit partnership amongst the public, the government, and the academic and research institutions. They all will have to play their parts together so that the decision making does not come directly from the top down to the bottom. That's where the problem has been, and that is the reason the public thinks all government projects are owned by the government and they don't have a stake in maintaining those projects, in managing those projects, and in fact, even in allowing the safe operation of those projects. For example, I give you a very practical example. The canals were constructed in many parts of India, particularly in northern India, as well as in many parts of southern India, in some cases more than 100 years ago. And the canal operation and management was essentially a top-down approach. In other words, the government officers essentially decided when to operate the canals, when to supply water, and what schedules to follow. And the same modus operandi is being implemented now. So the net result is that the canals are in sad shape. The canal water delivery schedules are so outdated that they simply do not conform to the current needs, the current crop needs, as well as the current weather needs and the climatic needs, as well as the needs of the public. The farms are no longer as they were 15 years ago because of the increased population, the farm sizes have declined. Because of climate change, cropping patterns have dramatically changed. Consequently, the crop water needs have changed, and yet the canal operation and management really have pretty much remained unaltered. And this is something that I'm sharing with you from my practical experience. As I said, I come from a village, and my family has a farm, and we grow all kinds of crops, and we have two canals, one flowing from north to south, another flowing from east to west. And yet, despite having two canals, you will find a huge upsurge in in water wells because those canals are not serving the needs of the farmer. And many times the canals basically run when there is no need for water, and they do not run when there is a huge need for water. So the farmers have pretty much lost faith in the operation of these canals because they don't supply water when the farmers need, and they supply water when they don't need. This happens all the time, and this happens season to season, year to year. So this is not a one-time event. This is a continuously occurring event, and unfortunately, the engineers or the canal operators live in Agra. They have no idea how the canal is operating, or how the canal is, whether or not the canal is supplying water and where it is supplying water. Every year or every now and then, there is a huge budget for maintenance of the canals. But if you go and take a look at the canal, those canals, I remember when I was a kid, we used to go and swim. Now those canals have become almost like a ditch, partly because of huge vegetation growth and sedimentation. So where is then the maintenance budget going? Nobody knows. These are some of the issues here. And the second thing then comes is, so what should be our approach to sustainable water supply? So as I said before, there has to be an integrated watershed management. And there has to be an integrated water sources management. And then, of course, we have to have multi-criteria, multi-objective, multi-constant decision-making. There will have to be a socio-economic evaluation. And then, of course, in all this process, we have to start using the actual data. And we have to start processing the actual data. It is not simply enough to construct a model or write an equation and then, based on which we write a paper. It has to have a grasp of practical reality. And of course, now we have to start using global climate circulation models to understand the future climate scenario, which may likely affect the basin. And then we have to start taking appropriate measures. Unfortunately, what happens is, because the wheels of governmental bureaucracy grind so slowly, that there often occurs a disconnect between the users and the suppliers. And the suppliers meaning the government forgets that the projects are for the users, in other words, for the farmers. Or if the projects are for supplying water to the urban areas, then it is the people for whom the projects are being designed, the projects are being maintained. So there has to be a proper feedback between the public and the government. And unfortunately, that feedback is seldom taken, and the feedback is seldom factored into the project operation and so on. And we don't learn from this kind of experience and bring that kind of experience to bear on planning and um, designing new projects. So we have to have conservation, efficient use, treatment, recycle, resupply, and develop additional resources. So the only way we can have a sustainable water supply is by doing all this. Meaning, we have to do conservation, we have to efficiently use the water, we have to treat the water. In other words, the water which is polluted has to be treated. We have to recycle the water, we have to reuse it, and we have to develop additional resources like desalination or wherever we can. So what are then the challenges or in water resources systems modeling? So the water resources have to be treated like a whole system, not just as a component. So the challenges are that our models have to be user friendly. And of course, we have to have model choices, and there should be a statement of model credibility. Only then the model should be used in rational decision making. So in terms of those of us who are engaged in modeling, I think we have to now start moving in the direction of making our models as user friendly as possible. And we have to also um, have the model provide a clear statement of their reliability, their credibility, their risk, their uncertainty, so that there can be a rational decision making about choosing a particular water sources system model. Now, let me make a remark here. User friendly means those people who use the model should be able to use it without knowing much about the model itself. Just like we use electricity, we don't have to be an electrical engineer to use electricity, or we don't have to use an automobile engineer to use a car, but they are designed to be very user friendly. The same thing we have to do uh, to our water sources systems modeling. So then, that gives a rise to a variety of research needs. In other words, the challenge presents an opportunity, and that opportunity gives rise to a variety of needs. So obviously, the needs start right from the data acquisition and access. We have to emphasize acquiring data, collecting data, and making the data accessible to everybody. The data should never be kept confidential. Also, our models have to be user-friendly and they should be easily accessible. Now, of course, I see in my village about 10 years ago, only my younger brothers had cell phones. Now, there is not a single person in my village who does not have a cell phone. Even the sweeper, the vegetable owner, even those who are not really much literate, but they have a cell phone. And many people have more than one cell phone. I carry only one cell phone, but my nephews and my brothers carry two or three cell phones. I don't understand this logic, but they do carry. In other words, they are able to use the cell phone technology. So what this means is that we as water resources engineer should be able to convert our water sources models, hydraulic, hydrology, ecosystem, whatever model we are working on, to the level that they are user friendly. The people who can use without knowing much about these models, and they should be easily accessible. The only way we can have these models in this manner, plus user friendly, plus useful, is that they are interdisciplinary. We have to start using the emerging tools. And of course, we have to have model choices and model credibility. Just like Just like you going to the market and buying a motorcycle or a car, you have a number of choices. So you can make a rational decision making based on how much your pocketbook allows and what your personal choices are and what your constraints are. So you can make a rational decision making, so which means we have to now translate our theory into practice. And we have to learn from practice to improvise our theory. So there has to be a continual feedback between theory and practice and theory. Those days are gone where there was a sharp boundary between theory and practice. It should not be anymore. Everything that is theoretical should be practical, and the practical should be able to provide input and information to the theory so that the theory can further improve and it can be made a lot better. Let's look at first the data. Of course, now we have all kinds of tools for data acquisition, particularly remote sensing and satellite technology, radar technology, we have digital terrain, elevation models, chemical tracer. Now, all these technologies are available in our country. I mean, we are one of the leading countries in terms of remote sensing and satellite technology. But this technology is not available to the common man. That is where my point is. Second, we still have not cultivated the culture of collecting data. In academia, I find that they still depend on the data collected in Europe and the United States. And we don't have large networks or large data acquisition and storage and retrieval facilities all across the country. If I want to get a data, we have to approach the central government or certain organizations that are charged with the responsibility of collecting data. That that restriction has to be done away with. Likewise, in terms of data processing and management, of course, people are using GIS systems and DBMS systems, but these systems have to be made so user-friendly that a common man who is not familiar with GIS and database management system technology can easily use. Now, I'm telling you from my personal experience because I evaluate a number of PhD dissertations, primarily coming from IITs and as well as National Institutes of Technology. And in these dissertations, I find that a lot of data is being used, uh, but that data is coming from the United States. I mean, that to me should not be acceptable. We have to have the culture of collecting data. For example, look at the case of Roorkee, where uh, two of my distinguished colleagues, Dr. Pandey, Ashish Pandey, and Vittanlal Kansal, very prominent academicians and researchers. And yet, if I ask them to, can you please give me the data for long-term data for a water set close to IIT, and they are almost at the foothills of the Himalayas. There are not too many institutions in the world which are so strategically located, right? Almost on the banks of the Ganges, at the banks of a major river, which is almost like a major canal, which is almost or even bigger than many rivers in the United States, and of course, almost at the foothills of the Himalayas. And yet, if I would ask them to supply me the data on a particular water set in the Himalayas, I don't think they can do it because they themselves don't have. That does not speak very well for the way we are doing research, the way we are doing water resources, the way we are doing hydrology. Now, of course, I'm not criticizing my friends because we have been friends for a very long time. It is not their fault. It is the way the system has been operating. And we have not taken the lead in reviving that system, in cultivating that culture. Every graduate student must have the sense of dealing with the actual data, not sitting in the offices and working on the computers without knowing the difference between wheat and barley. I mean, this is pathetic. So what are then the emerging tools that water sources systems analysis and decision making can take advantage of? Obviously, we have mechanistic models, we have data mining models, we have uncertainty analysis, we have, of course, entropy theory, risk analysis, we have multivariate stochastic analysis like Kapula theory, we have intelligence systems, optimization algorithm, decision support system, GIS, data collection and mining. All these tools are available, and students at IITs are using most of these tools. So the tools are available. There is no dearth of technology. There is no dearth of knowledge. But these tools are not being brought to bear on addressing practical problems that a common man can avail of. That's where uh, my my comment is. So I think we have to bring these tools to bear on solving practical problems for common men and make them usable for the common man. What should be our way forward? Our way forward has a number of components. First, we have to be innovative in our thinking. We have to be revolutionary in our thinking, and we have to be devising self-sustaining programs. Let me reflect on these. I think we should, when I look at a number of dissertations, and even now, actually, today I received an invitation. And today I received an invitation. Yesterday I received an invitation from two IITs, and I will not name them, uh, for evaluating dissertations. And normally I accept, but when I look at the dissertations, most of the time they are of very good quality, but they do not reflect an innovative thinking. They do not reflect an revolutionary thinking. They do not reflect self-sustaining technology. They are would be a PhD dissertations. I don't have any doubts, but I do have questions as to why we are not putting some of our best minds to more innovative thinking, to more revolutionary thinking, to more going thinking out of the box. We still seem to be dealing with the problems that we were dealing with 10 years ago, 20 years ago, in some cases, 30 years ago. Now, of course, there is nothing wrong in doing so as long as we can come up with really innovative, really revolutionary way of way of simplifying, or way of making things, in a revolutionary fashion, uh, usable. Then it is okay. Also, I think, as I said before, or at least I alluded to, we have to have a diverse and multi-institutional partnership. Again, let me go back to the example of Roorkee. Roorkee is a very unique place which has the distinction of not only housing an IIT, but also housing a National Institute of Hydrology, Irrigation Research Institute, which is a state government agency, as well as Central Building Research Institute. This is one place where you see three central government institutions, which are huge by any stretch of imagination, plus a state government agency, or more importantly, its location, which is so unique. And yet we have not taken advantage of this unique opportunity as well as the unique resources that we have. So one way to go forward is to um, start developing very diverse multi-institutional partnerships. And in other words, there has to be a partnership between academic institutions, government institutions, central as well as state, and even private institutions. So only then our we can make our way forward, and only then we can progress. And we have to start marching together. The third thing is we have to start valuing water for the only way, this is the only way that we can enhance the water use efficiency. Many people think water is very free or it values so little that we just don't care. And result is that even though we are a water rich country, and yet we have not uh, we have not cultivated the habit of using the water efficiently. So there has to be some kind of a pricing and valuing, even though this is a natural resource. Uh, the second thing is the fourth thing is that we have to have an integrated planning for water, energy, and agriculture meaningfully. I think we just cannot plan for water alone. There has to be an integrated planning for whatever we need as a society, as human beings. And so we will have to then build robust regional capacity. And so which means we have to have a different paradigm for development. There has to be a distributed development and controlled urban growth. Our emphasis when it comes to development primarily has been on point source development. And let me give you an example of this. Whenever we develop an institution, we want to develop only in the cities where already there are too many institutions. Why do we have to do it? If we want to develop as a nation, as a community, as a culture, as a society, then the development has to occur all over the place. In other words, there has to be a spatial development, more point development. And I'll come back to this a little later. So what is our future outlook? The future outlook is we have to, there will be an increasing societal demand for the work that we do, in other words, the model that we develop. And of course, there will have to be an increasing emphasis on linking these models to environmental and ecosystem models. There will have to be an increasing emphasis on mutual friendliness of these models. You will have to incorporate information technology, computer-based design, artificial intelligence, and space technology in most of the models that we develop, especially the large-scale model. And of course, each model will have to be coupled with a clear statement of uncertainty and reliability. And in other words, only then will these models be competitive. So we have to increase their competitiveness. And the models which can compete in the open market will be able to survive, the rest will die. And this is the only way we can actually progress. So if we re-examine based on our discussion, then we will have to manage our water, energy, food security system. So these three, water, energy, food, I will also add environment or ecosystem and health nexus. And this nexus, the five components, water, energy, food, environment, and health, these five components constitute what we call as nexus, and this nexus will have to be preserved, will have to be secured, will have to be nurtured. Nurturing one component will not do the job. And the only way we can do is that there is a very strong partnership among academia, government sector, the non-government organization, as well as the private sector. In all of this, the educational system will have to play a key role. And in this educational system, the two components that I will emphasize here is we will also have to train the trainers and teach the teachers. In other words, the trainers and the teachers also need to learn. The technologies are changing, the demands are changing, and what we learned 30 years ago, 20 years ago, even 10 years ago is no longer sufficient unless we make a concerted effort to keep ourselves abreast of the latest technology. And so only then can the educational system play a vital role in forging the partnership among academia, the government sector, NGOs, and the private sector. In other words, it is the educational institution that constitute the foundation that will really be the pillars for developing this kind of partnership. So where are we headed now as a society? I think our focus now will have to shift from development to management. We have done enough development, but we have to manage what we have developed. Whether it will have to be a paradigm shift. We have enough scientific and technological progress, but I'm not so sure that we have made an equal progress in our value system, in our social systems, including our political system. The global demographic landscape is changing. We cannot deny it. So this development and the social and scientific progress will have to be compatible with the changes that are occurring in the global demographic landscape, and particularly in India. The demographic landscape is changing. Even if we assume that the population is not increasing, the landscape is changing. The people are migrating from one place to the other, particularly from rural area to urban areas, even though many of the urban places are not really livable anymore. And yet, because of the way we engaged in the development of those areas, obviously that is where the education facilities are, the health facilities are, employment opportunities are, the transport facilities are. So the people naturally then flock to those places where the facilities are, despite the fact that the environment, the air quality, the water quality are not all that prone to living over there or maintaining a good quality life. So there will also will have to be changes in the way we nurture ourselves. We do upbringing of our children. We do provide education from the primary school all the way to college level. Because what we are witnessing these days is all kinds of conflicts and wars. Obviously, the human nature leads to competition, but the competition should be healthy and constructive. We obviously have to accept that all people will not have the same ideas, and they should not have. They should have different opinions. But these differences should be reflected, not uh, in terms of conflicts and wars, but more in terms of a healthy competition, more in terms of making ourselves better. It means that we'll have to integrate engineering, technology, socio-economic, and political science. They all will have to be brought together. Those days are gone where engineering projects will be designed simply using economics and engineering or technology. Those days are gone. If those projects have to be viable, if those projects have to serve the needs and the purpose for which the projects are being designed, that they will have to reflect socio, political, cultural ethos of the society for which the projects are being designed. Of course, they will be designed using engineering and technological principles, but the other considerations will also have to be factored in. So if we, now the time has come that we as a society or even as a country have to take a stock of what the current situation is. And we have to recognize our social and cultural constraints. And we have to take into account looming global changes. And we have to re-examine and re-evaluate our social and cultural values. The future can be bright or dark. It all depends in our hands. We can make it as bright as we want, or we can make it as dark as we want. But we will have to do the things that will help us make our future bright. So with that, let me reflect, let me provide you my personal reflection. Um, we have to understand that our land is finite. Our natural resources are finite. They may seem infinite, but unfortunately, they are not. They are not infinite. They are finite. Uh, Land cannot expand on the earth since the birth of the earth. The amount of water resources that it has not changed at all, not an iota. It is exactly the same. And of course, each country has finite resources, and the finiteness of resources continues to decline on a per capita basis with the increase in population. And of course, our standard of living has to has to take into account what our resources are. So we have to go back to what really the objective of life is, um, and based on which we should do the development. There has to be, as I said before, there has to be a shift in the development paradigm, and we have to always remember what really the human life is meant for, what exactly we are born to achieve. And always we have to remember the natural resources are God's gift. We must use them wisely because we owe it to our future generations that we leave them in a better shape than the shape we got them in. With that, let me um, open the floor for questions. Any question anybody has, I will be happy to share my views. Thank you.
Thank you so much, sir, for delivering a remarkably outstanding presentation. You have forced us to think about importance of water in our daily life, and also we need innovative ideas for conservation of water. Climate change is a great challenge for us. Due to climate change, temperature is increasing day by day, which is causing cyclones, floods, droughts, etc. We completely agree with this. Water, 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 everywhere water, but not a drop to drink. Now it's our responsibility to conserve this natural source. We can survive only by conserving the water, and it's the need of our. Sir, you have enlightened us by sharing your remarkable views, and also you have well spoken, sir. Our future can be bright or dark. It is all in our hands. We have to use resources with with our need. We do not exploit the natural resources. These natural resources are finite in nature. Thank you so much, sir. Now the stage is open to attendees for this webinar. If anyone has an observation or a question, he or she may kindly do so. Anyone? Happy, sir? Sir, sir.
Uh, uh,
Let us
uh,
discuss first, then we will go to
yeah,
questions
I think
from the audience. Yes.
Professor Singh has elaborated almost the entire canvas for the water resources professionals as well as
Yes,
for
sir.
the researchers. And I think it has set a very good tone for the researchers that what they should do and what are the normal problems which they face while doing the research. That is a very good aspect that he has done. Sir, I just wanted to have a curiosity to know that how this COVID is going to affect the water resources professionals or the research in the direction of the water resources sector. Because sometimes we are,
I think
and it is to me it is affecting almost all the aspects. But I think from your perspective, how do you visualize that how it is going to affect us?
I think that's really a very good question. First of all, obviously, it is affecting the environment, and fortunately, it is affecting the environment for good, for a change, and clearly is going to be impacting the water sector as well. Fortunately, actually, it is affecting in a positive manner. At least the pollution is declining, the air pollution is declining, the water pollution is declining partly because the people are staying home and they are not really moving out that much. So in a positive way, so far, what I read, what I hear, but clearly health-wise, then it is impacting obviously negatively. Lot of people have died, especially in the United States. More than 1,000 people have already expired, and more than 1.5 million people have been infected. Have been infected with COVID-19. So health-wise, and as I said, the water, health, food, energy, ecology, environment, and they are all related. So it will have an impact, but directly, I think, as far as I can see so far, the impact has been positive. Directly, water has not really impacted negatively. It will impact negatively only in terms of the disposal of animal waste. The people are dying, so you obviously have to dispose them in that sense. But largely, the rivers are
Sir,
looking a little bit cleaner.
another aspect is, I was just reading today and talking to the people. One issue is about the affordability of the water, because particularly under COVID, the people's income has gone down, and the accessibility of the water and the affordability of the safe and adequate drinking water, how it is going to affect us. That is the main issue. How it is going to affect
I
us.
think no, you are right. That, that is a very valid point. So far in the US, we don't have any problem. Actually, because people are now not really using any more water than they were using before. In fact, they are using a little bit less water because the people are staying home and they are able to maintain their houses, their homes, their landscape a little bit better than they were doing before. So overall, I think the amount of water consumption has gone up. Now, in terms of the affordability, because in the US, most people use potable water. The water is potable, so they don't really depend on bottled water. Now, your point is well taken. You are staying home and the water is more potable, but they use more bottled water, and it unfortunately it costs money. It bothers me quite a bit. Why we have bottled water? I remember the days when I was a graduate, when I was a student at Pantnagar or in the primary school or in high school. We never bought water. Water was available everywhere. And even when we used to go to Delhi, I remember when I graduated before coming to North America, I took a big position as an assistant engineer in the Rockefeller Foundation. And we used to go to Connaught Place in the evening for watching movies every now and then. And there used to be shops where they will actually give water for free.
Yeah.
There was hardly any charge for water. There was absolutely, it was all free. People will drink water everywhere without any problem. Now, bottled water has become a multi-billion dollar industry, even in the United States. It's a multi-billion dollar, it's more than $10 billion industry in the United States. So it is partly because, as they say, partly because it's a marketing strategy, but also partly because it is convenient. But people forget that not only they are spending a lot of money in bottled water, but also they are creating a lot of pollution. Now, the bottled water is in plastic bottles, and the plastic is not that easily biodegradable. And so, I agree with you that in terms of affordability, I think it's going to have an impact. In the US, so far, it has really not had any
Because particularly the people's per capita income has going very drastically down. I mean that people,
yeah.
that is a major issue which is coming now. Anyway, Professor
You are
Setia,
right, you are right, but
yeah.
no, but you are right. Many people are staying home, and many other people, including the US, because most of the working class belongs to class that does not have permanent jobs. So basically, they depend on their weekly wages or monthly wages, and we have been staying home, even though the government has been giving a lot of money. But how long can government keep on doling them out?
Yes, yes.
So, but the nice thing with the US is that the water is potable, so they don't have to worry about buying the water. They depend on the water that is coming off the tap. So for them, in terms of the cost, it has not has had any precipitable effect.
Sir,
How are you?
fine, sir.
It's good to see you after a long
Uh,
time.
yeah, it's been a wonderful, comprehensive talk. So I have a very specific question.
Sure.
Sir, we are the second highest receiver of rainfall in the world. We have
Yes.
been richly endowed.
Yes.
On the one hand, we have the problem of our teeming millions, but at the same time, we have been, God has been graceful to us that
It
we
has.
receive a
You
lot
are
of
right.
rainfall.
But
So, sir, in
we
that
are a land of gods and seekers.
sir, in that case, what is the role of actually management of this water?
I think
Why?
yeah,
Uh,
yeah,
if I can club it with something
yeah,
else, management,
yes.
of course, we have talked fairly comprehensively on that. So, uh, in India, water falls in the state list. I hope we are talking on the same frequency.
Mm.
If we include it somehow in our union list, can that be a master stroke for management?
I entirely concur with you. There are things that since the country got independence, we did not make a concerted effort. My argument is very simple. Water is a natural resource. It does not belong to any particular territory. It belongs to the entire country. And our river basins are interstate river basins, and some of the river basins are international rivers. For example, we share river waters between Nepal and India, between ourselves, likewise between Pakistan and India, between Bangladesh and India. So we have to, just like other natural resources, water resources should be the national property. It should not be a state property. The unfortunate part, and this creates the management problem. Even though, as you said, in terms of natural rainfall, we receive a lot of natural rainfall, but the regions where we receive the natural rainfall are relatively small regions, and the variability is very high. And unfortunately, much of the rainfall falls during a very limited span of time, which we call the rainy season. But even during the rainy season, much of the rainfall falls during only a limited number of rainy days. If you look at people often talk about rainy season, talk about 3 to 4 months. Yeah, but in 4 months, but we don't talk about the number of rainfall events during which we receive most of the rainfall. There are only few limited number of rainy days that we have, and that compounds the challenge for management. And obviously, that's the reason I was saying that we have to have not only science and engineering, but also socio-economic and political consideration into the management scenario, or else we will not be able to do it. Look at the case of Kaveri. There has been a fight between Karnataka and Tamil Nadu for more than 50 years, and we still have not been able to resolve it. Not only look at the case of Himachal Pradesh and Punjab, even though the rivers pass through Himachal Pradesh, but because of the agreement that was, I think, established several decades ago. I remember, I think, few years ago, there was such a severe drought in Punjab and Haryana. The Punjab government will not even allow Himachal Pradesh to take its own water, even though the water is passing through Himachal Pradesh. There has to be a broader consensus, uh, especially in the political arena at the national level. I think the political leadership has to rise above and transcend the narrow political confines and the narrow political interest. But the problem in democracy is how do you accomplish this? Even in the United States, we are also having pretty much the same problem. Of course, the quality of political dialogue has not declined as much as it has in India. So there has to be a much broader consensus, and there has to be a much higher level of national interest and not the local interest. But this will come only when the stakeholders are assured that their future will not be compromised. The problem is that we do not rise above our petty, narrow, self-centered interest. And partly it is because we do not assure them as a nation that your interest will be safeguarded. But the national interest should be viewed much larger than the interest of a particular province or particular state.
Sir,
Only then can we engage in what you termed as master stroke or development of a national plan. Otherwise, how else can we achieve it? And the way things are being managed, I just don't see how we can accomplish all this. We spend more energy on fighting each other than on supporting each other and developing the country. Look at the political dynamic. In parliament, much of the days, all that we do is just fight and do not allow the parliament to run rather than serving the people. So why should this happen? And there is no accountability. The thing that I did not emphasize as explicitly is accountability. For example, as a university professor, if you engage in a misdeed or ill behavior, you will be fired or you will be severely penalized. But how about a politician when the politicians make a decision which goes entirely against the interest of the public? How the politician is being held accountable? No politician is being held accountable, if I am not mistaken. Likewise, how about a bureaucrat? If an IAS officer or a bank manager, suppose a bank manager doles out a lot of money without due consideration, the bank manager gets transferred and basically remains impugned, no punishment whatsoever. On the other hand, there are certain sectors in the private sector, if you do a bad job, you will be fired. But there is no accountability in other sectors. So
India came up with a national water policy in 2012.
Yes.
But some states, they refuse to abide by it.
No, they refuse to abide because that's the way it has been. Yeah.
In fact, not only Kaveri or Satluj, Yamuna, etc. In fact, there are 36, more than 30 is what I could gather, cases lying before the tribunals to be settled, and they are in interstate, disputes.
Yes,
So-
you're right.
And that is the reason why most of this water, we say it goes unharnessed to the sea, but we are not able to manage it.
No, but that is where the political leadership comes in the picture. As a nation, all political leaders from all walks of life, from all kinds of political complexes, have to gather and rise above a narrow interest. And the only way we can do is when there is a consensus that this is a this is a national resource. It's not the resource belonging to a particular state. It is not a particular state's property. The same thing between, for example, look at Yamuna waters. I was coming from your institute to IIT Roorkee, and I passed through Yamuna Canal, and then I thought Yamuna Canal has more water than the Yamuna itself in Agra has. Yamuna is completely dry by the time it reaches Agra, even though it is considered as a major river. How can you consider as a major river when there is no water? And whatever little flow you witness in Yamuna in Agra is not freshwater flow. It is a sewage. So basically, Yamuna acts like a sewage canal. Basically, it's all polluted water which comes out of, it's a wastewater channel. And for the most part, except for a very limited period of time during the rainy season and a couple of months thereafter. That's all. Otherwise, basically, it just transports the wastewater being generated in the city of Agra and the neighboring area. So I completely agree with you. That's why I said it's true. There has to be a national dialogue, not only for water, but even in other area. And as a society, as a nation, we have to come to an agreement that look, it is in our larger interest, it is in the interest of all of us as a community, all of us as a nation, that we support each other, that we work together. And obviously, when we work together, everybody's interest cannot be considered supreme. Everybody's, some people will obviously have to do sacrificing, some people will be obviously gaining a little more, but as a society, together, all of us will be gaining. And the only way we can become a stronger nation is when all of us are strong. Just like you remember in engineering, when you take machine drawing, I remember I took machine drawing for a year and machine design for half a year. The when you design a machine, you try to make one part which is not as vital as the weaker part. So suppose there is an accident or something happened, the weaker part basically breaks down and the machine is safe. Likewise, I think, in other words, the machine will be stronger when all parts are stronger. The nation will be stronger when everybody is stronger, all states are stronger, all parts are developed. And that is why I always have had an objection, even when I was a student, why should all the development occur in Delhi or in Bombay or in Calcutta or in Chennai? The development should occur all over the country. That is one thing which people have to learn from the United States. In the US, all land grant institutions were established in the farmlands. Look at land grant institutions, say, for example, in Punjab, where Punjab TU is located in Ludhiana. Ludhiana is a major city, the center of manufacturing wool garment. In Madhya Pradesh, where is Jawaharlal Nehru University, Agriculture University located in Jabalpur? Jabalpur is a major city. I think Pantanagar in that sense is one of the few exceptions. They went out. Look at in Tamil Nadu, where is it located? In Coimbatore. And so how will students learn? A student does a degree in agriculture, but the student has a difficulty knowing the difference between wheat and barley. Because the student comes from an urban area. Yes, the student, it is not the fault of the student. The student has never seen the crops being grown on the farm. The student has never visited a farm. And so I think we have to get away from this very skewed way of thinking. And we have to come to terms with the reality of the world. And I was reading, to my pleasant surprise, an article, I think last week, in the statement being given by the Human Resources Development Minister. And now the development will start occurring in the rural area, so people will not have to migrate to major city, which is the way it should have been done 70 years ago. But anyway, late is better than never.
Yeah. Thank you. Mr. Ashish.
Hello.
Yes,
Sir,
yes.
sir, thank you very much for giving excellent talk. It was really very eye-opener for us as well as for students also. Sir, I am not asking question, I am just taking your advice. I have seen that in water resources, lot of students are doing research on climate change.
Yes.
And sometimes they are doing only trend analysis of temperature and rainfall data. And they feel that they have done a lot of things. But ultimately, what we have observed that it is giving you nothing because same data used by many people. And this is not going to say, not giving any output to us. So how to motivate students to divert their research toward water, energy, food nexus? How to motivate? Sir, this is a big problem This is becoming a big problem for us. Because every student, most of the time, they are doing this trend analysis, sense lobe estimator, some bias correction, and at the end they are saying that a lot of time we have lost in this work, 3-4 years we had passed, and ultimately no output is coming. So how to motivate our students? This is really a big issue.
No, I think you have made an excellent point. This is something I was trying to hint at without being too critical of the students whose dissertations come to my mind or come to me for evaluation. Even as I said, I got one request yesterday, and of course, before I receive a request from the dean of research, I get a request from the advisor, and the advisor is not to this. How can I say no? But this is what I find. What you are saying, Ashish, is very much on the mark. There are two ways to do it. One way is that there should be some, at least there should be one course, a qualitative course on challenging, on what resources challenges, what really the problems are, and what we really need to accomplish. This is one thing. In other words, the student should be motivated right from the beginning, and that kind of course should be made compulsory. It does not have to be necessarily taught by just one individual professor. It can be a team taught course, and where where there are no equations, there are no methodologies, only the question. Just asking a question. I keep telling my students, ask question. If you can ask the right question, you have solved half the problem. Finding the solution is not as difficult as formulating the proper question that will make a difference. That is one thing. That has to be taken by every graduate student, or for that matter, even every undergraduate student. It should be made compulsory so that the students really learn what the issues are, because half the time they do not even know what the issues are. Second thing, every PhD student must learn right from the beginning as to what they will be contributing. I was in a PhD defense of one of my students, 2 weeks ago, and this student has really done quite well, and he's a good student from Korea. And of course, after everybody asks a question, normally as advisor, I don't ask too many questions. But because they asked me to ask some questions, so I said, okay. So I thought I will ask a very simple question. So I asked him, his name is Kian Tae. I said, Kian Tae, can you please tell me what exactly the new thing that we found? Or what exactly is your new contribution to science or to hydrology in particular that you have made? You have spent 4 years and you have done well. You have written papers and you are writing more papers. But just tell me, as a layman, assume that I'm not your advisor. I'm like your family member, and I don't know anything about hydrology or about civil engineering, about water. So just tell me in simple terms, if you can explain in only 2 cents. I don't want it. Just only 2 cents. Tell me what new thing you have found. The student was so flabbergasted. He was so confused that he couldn't answer any question after I asked simply, and that's the only question I asked. The student should be told in no uncertain terms that this is a PhD dissertation. It is a terminal degree. You have to make a contribution, something that you will be proud of, something that you can show your own children when they grow up and start going to college.
Exactly the same way. I was just thinking this thing in my mind when you are talking about the training of trainers or the teaching of the teachers. I just give you the example. Even today, we were in presentation of one of the prospective faculty member for the IIT, and those candidates were PhD from a very reputed IIT or very high level degrees. But those people, when we ask a simple thing, a person has done PhD in the hydraulics, and I was asking just what is Bernoulli theorem. So if that person who has done PhD in the hydraulics, and then he is not been able to tell the what is the correct statement of Bernoulli's theorem, then how can we expect those people? So you are rightly pointing out the quality of the research, and basically, when we are doing any research, we should not lose the common sense, because everything is derived from the common sense, and we should think of how my work is going to help the society in directly or indirectly direct way, how we can help the society, and whether, because as engineer we should develop the analytical skill. If we are not being able to answer the questions as you have rightly pointed out, why I'm doing this one, how I can do this one, what is the use of this thing, so all these questions if I'm not being able to answer, then there is no meaning of carrying out this research. The second point which you have mentioned is about the data. I think when you have pointed out rightly that the data issue, most of the time we are only taking excuse of the data, and everything. But we are not answering that one, what for we are requiring this data. And second thing is, whatever we are taking the data, the reliability of the data is a big question, right? And most of the time, people are not sharing the data because they are fearing that if I share the data, somebody will point out the mistake in my data, right? So they don't have the confidence in the gathering the data or the quality of the data. These are some of the issues in the third world countries or even the countries like India, which is not the case probably in the US or something like that. So,
No, I agree with you, but coming back to the point that you were making earlier and Ashish made, I think I don't have any problems with the quality of the students that you have. I mean, they're pretty intelligent students, but they have to be motivated. They have they have to be um, inspired, so that they can marshal their intellectual strength and resources to bear on doing something very useful, something very innovative, something very revolutionary, which I'm not, I every year I would evaluate, I would say 10, 12 dissertations. It looks like some IITs and some NITs and some institutes don't find anybody else other than me. I don't understand why. But they have to just keep asking me. I evaluate one dissertation, submit, and the next 2 weeks later from the same institution, I receive another request. And because the request comes from my friend, so I cannot say no. But that is not the point. The point really is that in all of the dissertation, the students have spent a lot of time. There is no question, as Ashish, you pointed out, they do a lot of analysis. But the same analysis the students do because of one simple reason. They want to do within their own comfort zone the work which they do. And their comfort zone is defined by the laptop and the student offices and their own classmates or batchmates. They define their comfort zone and they feel that they can get by with it. But as soon as the student comes, if you put your foot down and say that, look, your thesis will not be approved unless your thesis proposal will not be approved unless you meet these requirements. Simply writing a paper is not enough. You have to produce something really innovative, something new, which will be useful, either even if it is not useful right away, at least it will be useful in terms of pushing the frontiers of knowledge forward. Or it will be useful in terms of bringing the theory to practice. So there has to be something innovative, or else PhD dissertation will not be should not be treated like a project report. And I'll give you a practical, and I will not name the university or name the professor. I got a PhD dissertation. It was prepared in civil engineering department uh, in Bangalore, and I will not name the institution. And I can assure you it is not ISC, but another university. It was prepared. So I said, okay, because the request came from one of the persons who I know. It was a few years ago, not, it was, I think, maybe 7, 8 years ago. And I looked at the thesis. I read the whole thesis. The thesis is submitted to the Department of Civil Engineering. You will be surprised. There was not there was not even 10% of civil engineering in. And what the thesis did was the person collected the data on sanitation facilities in about 50 households in Bangalore. So basically, it was a sociological thesis. So I read it. I said there is no engineering content in it. There is no equation. There is no graph. But that's not the point. I'm not interested necessarily in equations, even though I personally like equations. But it can be accepted. But there was actually no engineering content whatsoever. Zero initial content. It was just a survey paper they put together in the form of thesis. And this person was highly experienced. He was teaching in an engineering college. So I was very surprised that this person has been teaching engineering in an engineering college, writes a thesis like this, and the advisor accepts, and the head of the department accepts, and they send it. Obviously, I don't want to be blamed for destroying his career. So I wrote a nice review, and I said, look, this is submitted to a wrong department. It should go to sociology department because the thesis is a sociological thesis. And I did not reflect on the quality or anything, but I wrote a one-page letter explaining why I think it should go to the sociology department, not civil engineering department, because there is no civil engineering, not even 5% civil engineering in there. Civil engineering means sanitary engineering because it dealt with sanitary engineering facilities like toilets and so on. Now, so what are we doing as a society? What are we doing as an educational institution? We cannot keep on blaming politicians and bureaucrats and everything. But this thesis came from the university. So the blame has to be shared primarily by the advisor, not only by the candidate, because it's a candidate thesis, not advisor's thesis. And the people have to understand that the student is the one who will receive the degree, not the advisor. But the advisor is to be blamed because it is the advisor who is signing that the thesis is worthy of a PhD dissertation. And this work it rises to the level of a PhD dissertation. And then the administration also is to be blamed because the administration is also signing. The head of the department is signing. So the head of the department simply cannot make an excuse that this is the responsibility of the advisor. If that is the case, then he should not sign it. Then they should change the rules. So the question really I'm making is that the PhD dissertation is becoming more like a routine thesis and not a PhD thesis that basically should be. It used to happen in olden times that a PhD dissertation actually made a discovery or established a theory or derived new equations or developed a new methodology. And I can cite a lot of instances, not only from hydrology, but also from particularly from physics and mathematics. Yeah, this was the case. But now, I think in the process of increasing the numbers or enhancing our resumes, or I don't know what the issue is, or because the government is spending a lot of money, the government is putting its trust in educational institutions, and it is the responsibility of the educational institutions to maintain the quality. And if a person is not capable of supervising a thesis of a particular kind, that person should simply say, no, I don't work in this area. Or they should invite other people to serve as co-advisor. So I think that, to answer your question, Ashish, it's a shared responsibility between the advisor and the institution as well as between the department. And one way to bring about a difference, maybe if I happen to spend the next semester, a semester next year, maybe we should engage in a dialogue. Don't worry about the emphasis should not be on offering courses. Emphasis should be on opening up the mind, these young minds, and encouraging them to ask questions themselves and challenging the faculty members. But look, this is the way it should be, and that's what we would like to do. They themselves should be motivated enough to feel that they should make a difference. Yes, you will get a degree, but getting degree is not as important as making.
Yes.
And that is we should be doing. I think that is one of the things I like to do. Have all the graduate students and just engage in freelance seminars, or maybe take them to a restaurant and sometimes you get some new ideas just by having a freelance discussion and motivating them into thinking big. The first thing that people have to think is think big. You think big, you speak big, you act big, then of course you become big. You don't become great simply by thinking at a low level, a junior level. The objective should be really to think big. And I can assure you, people are capable. They can accomplish big things. But they have to be motivated into thinking that they can accomplish big. And they have to be convinced. They have to that they can accomplish it. They should not be told that you write one or two papers and you can get by with it. They should be told in clear terms right from the beginning that you have to make a contribution, or else you will not get a degree. And then of course they will start. You will be
Okay,
surprised.
I
They
think
will be
we can ask this, because if there is any youngster want to ask anything, probably.
Yes, yeah. It was meant to be for them. That's what Vikas told me. No equations, no graphs. It should be very qualitative because it should be.
So actually, even we want you to try this opportunity, because whenever you are in Roorkee, you are very busy. So many people are surrounding you. So I thought I will ask from you.
No, because
No, no, no.
we keep on discussing
No, no,
with
no.
Professor VP Singh quite often. But I think if any youngster want to ask anything or any query, he is most welcome. Because, are you there?
I think Vikas has lost connectivity. So Neeraj wants to say something, I think.
Yeah.
Neeraj, I see his hand raised. Vikas is out of the meeting for a while, I suppose.
Because I saw him just a few seconds ago. He was on the screen.
Yeah.
Yeah, now he lost connectivity. This is what he conveyed.
But
Neeraj has raised his hand.
Otherwise, Professor Setia, we can thank Professor Singh. He has spent quite
I
a
think
good
Neeraj wants to say something. He wants to thank. Neeraj? Neeraj, can you hear me?
I think all of them have probably lost the.
No. Neeraj would be concluding it. This is what I was conveyed.
He looks to be there.
Vikas? Vikas? Can you hear me?
Hello.
Yeah.
Hello.
Yeah.
Hello.
Yeah, he's back.
Hello.
Yeah, Vikas, I can hear you.
Yes, sir. Yes, sir.
Yeah.
Vikas, can you conclude?
Yes, sir. We will conclude. And I think there are few questions from the young participants. Can I take one or two?
You can ask as many
Yeah,
questions.
I will send a mail to sir.
Yeah. Professor Singh will like to answer that one. He rather would love to answer those questions.
Okay, sir. Thank you so much for the Dr. VP Singh. Hello.
Yes, yeah, I can hear you.
For a yes, actually, sir, I am getting echo of the voice. I'm not able to getting voice. Sir.
Others may
Thank you,
mute their mics.
Professor, for wonderful lecture. It will surely go a long way in training the students and faculty on importance of water management for sustainability. On behalf of CUH, I thank you, sir, and Professor Baldev Setia, Dr. ML Kansal, and Dr. Pandey for attending the session, for sparing their valuable time, and And I will also like to thankful. I would be thankful to all the participants. They have spared their time and attended this webinar. And I got the comments from the participants. They were very happy from this webinar and got very good knowledge. And they are very thankful to the sir for conveying this lecture and presenting this. And and at the last, I would like to thank for all for this session. Thank you so much, sir. Thank you.
Thank you.
Thank you very much, sir, for sparing the time and interacting with us. We are really
Thank-
thankful to you on behalf of IWRS as well as on my personal behalf and on behalf of IT Roorkee. Rather, we feel you as a family member, but still as an elder member, we thank you very much for being with us.
Thank you. It's always a pleasure seeing you and Archie's and Dr. Setya and Vikas and other friends. I'm glad that you all are safe and healthy under the specter of this COVID-19. So,
Thank you very much, sir. I hope you take care of your health also. I hope you are maintaining good health. Thank you very much, sir.
Yes, I place on record my gratitude. Thank you so much. Thank you, everybody.
Thank you so much.
Thank you.